in some occasion, it is in the shape of a T. Or if you see some precast pre-stressed bridge girder, they are I in shape. No, they look like they shape like I. Okay. So there could be so many shape of reinforced concrete section. It's not only limited to rectangular and T, but time of discussion is limited. So that's why we limit only to rectangular and T. Not only that they are the common shape, we limit only to two because if you need to analyze different shape, the procedure is just the same. You just follow the procedure of rectangular and T-beam. Only the shape will be changed. Okay. And besides, it's not good to dwell on this while other topics has to wait. Okay, so we limit only up to T-beam, then we discuss to the other. Number three is design of flexural strength of reinforced concrete. So the same, this is just the same as number two, but we put more emphasis on design. So two and three are somewhat related. Number four, analysis and design for shear. So earlier, we discussed about the importance of the ring or the stirrups or the ties, or engineering term, we call it shear reinforcement. Okay. Why do we provide reinforcement? It's because the section is subjected to shear forces. So aside from the bending forces that is acting there, there is also shear. Sometimes shear and torsion are somewhat very near to each other. So that means that if you provide reinforcement for shear, you also provide for torsion. Okay. But there are beams that are subjected more of torsion than more of shear. So, but the analysis for shear and torsion are similar. In fact, they share the same formula. So that means that we discuss the design one by one, no? One for bending moment shear. Okay. But later on, once we know already how to design for bending moment and shear, we apply all of this. No? So number five is torsion, and number six is that actually from three to five is only good for beams, no? Because beam is subject to bending moment, shear, torsion. But when it comes to compression, this is uh, somewhat appropriate for columns because columns are subjected to compression member, to compression force, compressive force. So chapter six number, I think this is number the course outline. Six is about design of columns, and number seven, no. So out of the seven topics, so the last is the pre-stress. So only a little about pre-stress, no. So once we understand already the principle of reinforced concrete, and we know already how to design, uh, at this time when we are already seven, this is already at the last week or last 2 weeks of the summer. So we have only, I think, a very small time remaining. So not much time to discuss a very big topic of business. That's why it's only up to this. Okay. And also, you can use also some of the principle in reinforced concrete in pre-stress. No? Just like the topic of shear in pre-stress and reinforced concrete are the same. The topic of torsion on in reinforced and pre-stress are the same. Only the topic of the main reinforcement, as pre-stress uses high tensile strength reinforcement and high compressive strength concrete. Okay. So these are the reference. You can use the ASIP, no? ASIP contain almost all. Can use also the ECI. You can also use books just like authored by McCormack. You have also by Winter and Nielsen and Wang Chukya Salmon. Wang and Salmon. So I have here, I will show you. Uh, I will show you the book of Wang and Salmon. So uh, this one is the Berhibi in ECP book. So I think you have this. No? This is the latest version, 2015 pa. They say that they will come up with a new edition, but it's already 2021. They have not come up with a new edition of this. They did due to the pandemic. But if you have this, or this serve as a handbook of civil engineers in the Philippines because all are here. You can have reinforced concrete, you can have steel, you can have pre-stress, you can have design of foundation, everything, wind engineering, earthquake engineering is here. Okay. I have also one by, this is by Chukya Wang and Salmon. No? So this book is very nice. But I guess some of the e-copies are already circulated in the internet, so you guys do not have trouble accessing this book. All you have to know is the author. So that's it, no? So in my first in the introduction, I mentioned the importance of reinforcing the tension part of the member. So because you have already passed your theory of structures and with the use of software, it must be easy for you to look for the tension side of the structure. And once you know the tension side, you have to reinforce there because it needs the presence of the engineer. No? So that's where we are called for, no? To reinforce the weaker part, no? To help the weak. Okay, to reinforce the weaker part of the section, which are the tension side. Okay, and you also have to reinforce the the compression side. Okay, and also not only because the reinforcement that I am talking is only for the flexural reinforcement or bending moment. There is also a need to provide stie wraps or shear reinforcement because if we look at the shear and moment diagram, there are parts of it that is heavily sheared. Now, if we do not reinforce it, you will fall by shearing, no? By shearing. And also there are parts that are where moment is heavy, so there is maximum moment there, so you need to reinforce. So there are also parts which are subjected to torsion, no? Torsion. So you are going to put some torsion reinforcement, and as I have mentioned earlier, torsion and shear reinforcement are somewhat similar. Okay. So I also discussed uh, the topics, no, which we most likely you most likely encounter in my lecture. Okay. So that is just discussing the course outline. Then we'll go to lecture. We'll prepare uh, what we call this document file where to stick all our lecture this morning. Okay. So I will show this to you, and then we'll just fill this up, no, as much as we could. Okay. So does this appear already in your screen, class?
Yes, sir.
Okay. This will be our lecture notes for this morning. So maybe first we define what is concrete, no? So concrete. Okay. So as a beginning, no? As a beginner, as a fun. So We will fill this up, the definition of concrete. I will go to uh, Google. I will Google this. No, so it's good that we have Google. You don't have to find it in other references. So what we will do is just type it, and as I have mentioned to you, you can learn by just you can learn anything from the information in the internet because internet is very rich in information. So soil type concrete, concrete meaning. What is meaning of concrete? Meaning. We just want there are so many meaning I think, but we just pick one of the one that makes sense, especially the technical one. Meaning of concrete. Okay, this one, no? Concrete. Okay. So, okay, I will make this. Okay, so it says here that concrete. Okay, concrete. A heavy wrap building material. Okay, that's correct. Heavy means yeah. So, you don't have to rebut on that. A heavy wrap building material made from mixture of broken stone or gravel, no? Sand, cement, and what the most important is water that can be sprayed or poured into molds, and that forms a mass resembling a stone on hardening. So it once it hardened, it becomes stone-like mass of solid. Okay, so I think we are already okay with this. No, this is not okay. So I'm okay. I hope you're okay also with this. So we'll go to reinforced concrete. We'll just say that I'll just add concrete. Concrete is strong in compression. This is what we know: compression and weak in tension. Uh, that's one that I always uh, emphasize in my lecture a while ago that concrete is weak in tension. Okay, weak in tension. Okay, let us. I will also. So this is the stress strain. Stress strain of concrete. Concrete, yeah, concrete. So how does it look like? Okay, okay. So maybe all of you have experienced breaking a concrete cylinder, right? Did you do this in your material testing class?
Wala, sir.
Wala mo nakabuak og concrete? Ngani? Wala mo nakaagi og breaking of concrete using the universal testing machine?
Wala, sir.
Wala sir, kay online na sir.
Okay, this is how to determine the compressive strength of concrete, and if you plot it, you can determine the elasticity of the concrete. No? So the concrete here is a cylinder, but you've seen cylinder samples. You've seen cylinder samples such as this. These cylinder sample are specimen, no? They're the specimen to be used in testing the strength of concrete. So they are crushed by this machine. This machine is either compression machine or the universal testing machine, because only the universal testing machine or UTM and compression machine can crush concrete sample. This one. Okay. They will crush it, but they will monitor the crushing because the crushing is a bit very slow. So stress is being applied longitudinally, and then little by little increasing it. Then there will be some shortening of the concrete is recorded. Now the shortening over divided by the overall length could be the strain. No? That's the formula of the strain. The elongation or the shortening divided by the original length of the sample is what we call the strain. So they are plotted here. So this plot is a two-dimensional plot. The vertical is the stress, meaning the force per unit area of the cylinder sample, while the abscissa is the strain. Okay. As you apply the load, the the length also shortens. There's a micro shortening, in terms of micrometer. So that's why the plot moves in this way. Okay. So if the strength of concrete is denoted as F prime of C. F prime of C ang alam na niya, no? Muna siya ang pinakataas na strength sa concrete before it fail, before siya mabuto, before siya mo collapse, before siya mo fail. Failure here is cracking, bursting, would be crashing. So that's it. So as the concrete is being stressed to its limit, and the manner of stressing this is very slow, so it can be recorded. No, this before we record this using micrometers, but now it can be recorded using the transducers or maybe sensors. No, there are transducers attached to this, so any movement can be determined. So in other words, you can digitize the plotting. It's the computer will plot. No, you need some software and some sensors or transducers to be attached to some interface into the computer. Okay, so the computer will just give you a window of what happened during the testing. So this is it. No, the stress is vertical, strain is the horizontal. Stress is defined as force per unit area. Strain is defined as elongation per unit length. Okay. So as the stress is being applied, there is what we call the straight line. Now the straight line is the basis for the initial modulus, and then it will give you a curve to this. Then it reaches up to its ultimate. Then once you know that because the graph will subside. Then this time the sample breaks. So this is the what we call the stress strain plot of concrete diagram of concrete. Okay, so I'll say that. So that is how you determine it. Okay, so now let us see what is the tensile strength of concrete. Tensile strength of concrete. Okay. Let us say FC prime, F prime of C is the, let us say compressive strength of concrete is FC prime. Is denoted as F prime of C. So take note that this is F prime of C. So it is the, what is F prime of C? It is the maximum strength that the concrete attain in a crushing of concrete, in a compression test of concrete. So I will say put here compression strength, compression test of concrete samples is done using compression machine. In Xavier University, you have compression machine and universal testing machine using compression machine or UTM. No, UTM. Universal testing machine. Okay, I will put here universal testing machine. Okay. Below is the stress strain of concrete. Now, strength of concrete vary. It's not constant. It vary due to the kind of aggregates, the amount of sand, the amount of concrete, and the amount of water. So it always, you always have to test the concrete, what is actual strength of concrete. It's not universal. It's not constant. Concrete is very variable. Okay. So concrete strength, I will put here. Concrete strength is variable. Daghan kay factor, no? Daghan kay factor involved. In fact, if you try to go back, what is the ingredients of making concrete? It is composed of gravel, sand, cement, and water, and maybe some admixture. Okay. Okay, so the ultimate strain of concrete is 0.003. No? So take note of that. Ultimate strain of concrete, ultimate strain of concrete is 0.003. Mao na siya, ultimate strain of concrete. So there are many things that we want to know about concrete, no? What is the tensile strength of concrete? Maybe first note, we will put modulus of elasticity. Modulus of elasticity of concrete. Modulus of elasticity of concrete is not constant, but we can assume, no? So usually we just go to the formula. No, we just type it in the Google. Now we just Google. Okay. Google.